Hello, so in today's class we will begin module 4. So in module 4 we'll be starting with function of more than one variable. അപ്പോൾ നിങ്ങൾ ഇത്രയും കാലം പഠിച്ച ഫംഗ്ഷൻ എന്ന് പറയുന്നത് that is of the form y equal to f of x. So that is a function of single variable x. So we will look at അപ്പോൾ നമ്മൾ single variable നമ്മൾ ഒത്തിരി കാര്യങ്ങൾ ചെയ്തു. We have defined what are limits, what are continuity, then how do you say that function is differentiable, derivatives എങ്ങനെ കണ്ടുപിടിക്കാം, integrals എങ്ങനെ കണ്ടുപിടിക്കാം. So we have seen many things. So how to evaluate the derivatives orders. Now when you come to function of more than one variable, so there you will have more than one independent variable there. So when you represent the function in the form y equal to f of x, so there x is called the independent variable and value of y depends on the value of x. So y is called the dependent variable. So by function of several variables or function of more than one variable, you mean there are more than one independent variable. So we will look at how to define. Single variable when you start with a function, first you look at whether a function is defined or not. Domain endana, range endana, anganathe karyangalanu nammal identify cheyyunnu. Then we have seen sketching of the function. So when you have function of more than one variable, we will look at how sketching possible aano, എല്ലാ കേസിലും പോസിബിൾ അല്ല. ഇനി നമുക്ക് എങ്ങനെ അതിന്റെ ഗ്രാഫ്സ് ഐഡന്റിഫൈ ചെയ്യാം. Then we'll look at the notions of limit, continuity and differentiability. Then we'll learn a new concept called the partial derivatives. So when you have more than one variable, so instead of derivatives, so together with derivatives you will have what is called partial derivatives. അപ്പം നമ്മൾ differentiability define ചെയ്യുന്ന പോലെ here you can define derivatives with respect to each variable. അപ്പോൾ നമുക്ക് more than one function എന്ന് പറയുന്നത് depends on more than one variable. So with respect to all these variables, your function is changing. So there, when you have more than one independent variable, you will have the notion of partial derivatives. So our main aim is to introduce what are called partial derivatives. ബാക്കിയെല്ലാം നമ്മൾ just നോക്കി പോവുള്ളൂ. The initial definitions and limit, continuity, differentiability of function. So the main interest of module 4 is what is partial derivatives, how to find the different partial derivatives, then how does chain rule work in the case of function more than one variable. അതുപോലെ നമ്മൾ single variable we have seen how to find the maxima, minima, absolute maxima, absolute minima. So how does that work? So here instead of first derivative and second derivative test, you have the first partial and second partial test. So we will look at what are those tests. Okay. So the main topic of fourth module is partial derivatives. അപ്പോൾ ആദ്യത്തെ കുറച്ച് സെഷൻ function of several variables introduce ചെയ്യുന്നതാണ്. Okay. So in today's session we will define function of two or more variables. Okay. So the most common function of two or more variables is, so if you look at area, so if you look at area of a triangle അല്ലെങ്കിൽ area of a rectangle, so area of a rectangle that depends on both length and breadth. ഇനി volume എടുക്കുകയാണെങ്കിൽ volume depends on length, breadth and height. Now if you are looking at temperature at a point in the space, that depends on the x coordinate, y coordinate and z coordinate. So any point, any spatial point, that's a function of three variables. So it depends on x, y and z. Similarly നമ്മൾ മോസ്റ്റ്ലി ഡിഫൈൻ ചെയ്യുന്ന എല്ലാ ഫങ്ഷൻസും, നമ്മൾ റിയൽ ലൈഫിൽ ഡീൽ ചെയ്യുന്ന എല്ലാ ഫങ്ഷൻസും മോസ്റ്റ്ലി മോർ ദാൻ വൺ വേരിയബിൾ ആയിരിക്കും. അതായത് നമുക്കൊരു കാര്യത്തിനെ പറ്റി പറയണമെങ്കിൽ നമുക്ക് ഒന്നിൽ കൂടുതൽ വാല്യൂസിനെ നമ്മൾ ഡിപ്പെൻഡ് ചെയ്യും. സോ മോസ്റ്റ്ലി in the real world problems you are going to deal with function of more than one variable. So in our നമ്മൾ initially we are going to mainly study about function of 2 variables and 3 variables. Okay, so the representation of function of 2 variables is in this form. So we usually express it in the form z equal to f of xy. But here this means z is a function of x and y. So corresponding to the value of x and y, we obtain x and y are the input values. അപ്പോൾ നമ്മൾ ആ input values കൊടുക്കുമ്പോഴാണ് നമുക്ക് z ന്റെ value കിട്ടുക. So here this values x and y, this variables x and y, they are called the independent variables, and value of z depends on x and y. So they are called the that is called the dependent variable. So here z is a function of x and y in the sense that a unique value of the dependent variable z is determined by specifying values for the independent variables x and y. Okay, but when you give the values of x and y, you will obtain a unique value of z. So here x and y are called the independent variables and z is called the dependent variable. Similarly, when you have a function of 3 variable, this is one of the notations. So we define it as, we usually denote it as w equal to f of x, y, z. So w is a function of x, y and z. So here there are 3 independent variables and 1 dependent variable. Okay, and if you have a function of n variables, so this is another way of representing denoting your function of n variables. So you can denote in the form u equal to f of x1, x2, etc. xn. ഇനി നമ്മൾ സിംഗിൾ വേരിയബിൾ ഫങ്ഷൻസിന് കാണുന്ന പോലെ തന്നെ here the definition of domain and range are the same. So by domain you mean that is the set of all values for which function is well defined. Okay, അപ്പോൾ function defined ആയിട്ടുള്ള values ആണ് the set of all values where your function is well defined, that is called the domain. അപ്പോൾ ഇവിടെ നമ്മൾ സിംഗിൾ വേരിയബിൾ ഫങ്ഷൻസ് ഡിഫൈൻ ചെയ്യുമ്പോൾ that is from some subset of R to some subset of real numbers to subset of real numbers. So here your domain will be, ഇപ്പോൾ നമ്മൾ z equal to f of xy ആണെങ്കിൽ the value of the domain, നമ്മുടെ ഇൻപുട്ട് വാല്യൂ എന്ന് പറയുന്നത് നമുക്ക് അവിടെ എക്സും വൈയും ഇൻപുട്ട് വാല്യൂസ് ആണ്. അപ്പൊ നമ്മുടെ ഡൊമെയിൻ എന്ന് പറയുന്നത് ദാറ്റ് ഇസ് നൗ സബ്സെറ്റ് ഓഫ് ആർ ക്രോസ് ആർ, അല്ലെങ്കിൽ 2 dimensional സ്പേസിലായിരിക്കും നമ്മുടെ ഡൊമെയിൻ വരിക. ഓക്കെ, സോ വി ഹാവ് the domain as the 2 dimensional space. ഇനി അതുപോലെ തന്നെ if you have the function w equal to f of xy z, അപ്പോൾ അതിന്റെ ഡൊമെയിൻ എന്ന് പറയുന്നത് that will be a subset of, because value of w depends on x, y and z. So that will be the 3 dimensional space. 3 dimensional സ്പേസിന്റെ ഏതെങ്കിലും ഒരു സബ്സെറ്റ് ആയിരിക്കും നമ്മുടെ ഡൊമെയിൻ എന്ന് പറയുക. സോ ഹിയർ there is that difference. ഇനി നമ്മൾ we look at how to find the domain. So domain നമ്മൾ കണ്ടുപിടിക്കുന്ന യൂഷ്വലി നമ്മൾ സിംഗിൾ വേരിയബിളിന് ചെയ്യുന്ന പോലെ തന്നെ. സോ അണ്ടർ എ സ്ക്വയർ റൂട്ട് വാല്യൂസ് പോസിറ്റീവ് ആയിരിക്കണം, ദെൻ ഡിനോമിനേറ്റർ മസ്റ്റ് ബി നോട്ട് ഈക്വൽ ടു 0. അപ്പൊ ആ കണ്ടീഷൻസ് ഒക്കെ വെച്ച് തന്നെയാണ് നമ്മൾ ഇവിടെയും ഡൊമെയിൻ കണ്ടുപിടിക്കുക. സോ there we will obtain a condition involving the 2 variable function ആണെങ്കിൽ we will obtain a condition involving x and y. 3 variable ആണെങ്കിൽ you will get a condition involving x, y and z. So which will be subsets of the 2 dimensional or 3 dimensional space. So this is the definition of your function of 2 variables. So a function f of 2 variables x and y is a rule that assigns a unique real number f of xy to each point xy in some set d in the xy plane. So here d is the domain, so that is the subset of the xy plane. And similarly, a function of 3 variables is a rule that assigns, so corresponding to every x, y, z in a given domain D in the 3 dimensional space. So corresponding to x, y, z, you will be assigning a unique real number f of x, y, z. And now let us look at a problem on finding the domain. So here you are given f of xy equal to root of y plus 1 log x square minus y. So you are asked to find f of E0 and sketch the natural domain. So for finding f of E0, for substitute x equal to E and y equal to 0. So y equal to 0, you will get root of 0 plus 1 plus log E square minus 0. So that will be root 1, which is 1, plus log E square. So that will be 2 log E. Log E is equal to 1. So you will get 1 plus 2. That will be equal to 3. For finding the domain, up here you have a square root. Under the square root, the value must be always greater than or equal to 0. For y plus 1 must be greater than or equal to 0. അതുപോലെ for the second function to be defined, log in the value defined when you define log x, x must be greater than 0. So log x square minus y is defined only when x square minus y is greater than 0. So that gives y less than x square. Appam നമ്മുടെ domain, so domain will be set of all xy such that, so that will be set of all xy such that, so you must have y plus 1 greater than or equal to 0 and y must be less than x square. So y equal to x square na arayna, that is this parabola. So y is less than x square, that means that will be the region below the parabola. Ini y equal to ഇവിടെ equality ഇല്ലാത്തതുകൊണ്ട് parabola include ചെയ്യില്ല. So that's why you are representing it by a dotted curve, and y equal to minus 1 is this line. Okay, അപ്പം parabolയുടെ താഴേക്കുള്ള region y equal to minus 1 മേളിലേക്കുള്ള region നമ്മുടെ domain. So domain is this intersection of both these. So that will be this shaded portion. So the domain will be the region lying below the parabola and above the line y equal to minus 1, including the line y equal to minus 1. അപ്പം നമ്മൾ സിംഗിൾ വേരിയബിളിനെ ചെയ്യുന്ന പോലെ തന്നെ look at what are the conditions for these function to be well defined. Okay, അപ്പോൾ under square root ആണെങ്കിൽ പോസിറ്റീവ് ആയിരിക്കണം, ലോഗ് ആണ് വരുന്നെങ്കിൽ greater than 0 ആയിരിക്കണം, ഇത് greater than or equal to 0. ഇനി denominator വരുന്നുണ്ടെങ്കിൽ denominator not equal to 0. So that's how you find the domain. So in this case, so let us see one more example. So you are given the function f of x by z equal to root of 1 minus x square minus y square minus z square. So you are asked to find f of 0, 1 by 2 minus 1 by 2 and the natural domain. So substitute 0, 1 by 2 minus 1 by 2. So that will give root of 1 minus 0 square minus 1 by 2 square minus 1 by 2 square. So you will get 1 minus 1 by 2 varum. So that is root of 1 by 2. Ini again under square root, the domain kandupidikkan under square root, it must be positive, greater than or equal to 0. So you will get 1 minus x square minus y square minus z square greater than or equal to 0. So that is x square plus y square plus z square will be less than or equal to 1. Now this is the sphere and its interior. So the domain will be, so that will be set of all xyz belongs to R3. So R3 is the 3-dimensional space, so such that x square plus y square plus z square is less than or equal to 1. So R3 is the Cartesian product R cross R. So this is how you find the domain. So domain is all points within the sphere and including the sphere.